Okay, we're going to get some binomial probabilities, which are some of the easiest marks that are out there. But we do have to be careful, okay? And the only way to do this reliably is with a diagram. And because this is discrete data, we have to be very careful with our inequality signs, because the question will always be, am I allowed to have this 4 or not? So if I've got an n of, so the first thing to do is to read this. This is saying x has got a binomial distribution, and the 8 is my n, and my 0.3 is my p. So that means the number of successes, I'm counting the number of successes out of 8 trials, so it could be anything from 0 up to 8. Now I could write all the numbers out from 0 up to 8, but normally, if I'm feeling a bit lazy, as long as I've got this 4, and I've got the 3 that comes before it and the 5 that comes after it, I can put ... I should maybe finish with the 8. But that's easily enough of the numbers for me to work out what's going on. Now I want the probability of being less than or equal to 4, so I could have 3, I could have 0, I could have all the numbers between 0 and 3, and crucially I can have 4, but I can't have 5, I can't have any of the others up to 8. Okay? Now, we now draw potentially 2 boxes. We draw a box that includes all the ticks. Okay, so starting from the left, how far do I have to come in order to include all the ticks? Well, I need to come that far. Okay, and in fact, I'm just going to need one box, because this is what your calculator does. In fact, this particular example, because it's directly what your calculator does, you could actually go straight to your calculator, but I want you to be in the habit of drawing the diagram for everything. So we can do the probability of x less than or equal to 4. Now to do that, we need in the main screen, for the first time, we're going to use mode 7. So mode 7 gives us some distributions, but none of these are what we want. We do not ever use binomial PD. The only one we ever use is binomial CD. So to get that second page, I'd press the down arrow, binomial CD, option 1 on the second menu. This is what we want. We're going to use variable for the first batch of these calculations we do. So we press 2, and now it's asking for 3 things. It's asking for n and p, so we always set up n and p before we start. But the x is the value that we want to be less than or equal to. So in this case, actually, it's all set up correctly. We want to be less than or equal to 4. So my x value is 4, and my n and p value, if I already decided, n is 8, and p is 0.3. And I press equals, and it tells me that my probability is 0.9420. There's no working I can show, so I've just got to be sure that I get that right. It's all or nothing in terms of the marks for this one. Okay, but after this there are some marks that I can get for showing my working, because none of the others is just going to be a single straight use of this number on the calculator. They've all got a bit more to them, and this list of outcomes becomes totally not optional. So here I want 0, I'm going to go up to 8, I need 3, and I need the value on either side of the 3, and I can put ... here and ... here. Now what am I allowed here? I can have less than 3, so 0's alright, 2's alright, but 3's not alright, it's got to be strictly less than 3. All of these are not alright, so therefore the probability I need, well, my calculator deals with less than or equal to probabilities. So what can x be less than or equal to? Well, I draw my box. My box that includes all the ticks goes up to 2 and goes down again. All of that box is ticked, so I don't need a second box to take away. I just need to look up the probability of x being less than or equal to 2. And since I've just done one with the same n and p, if I press equals again, I just change that x to 2. Press equals a couple of times, and I get the probability, which is 0.55177. Okay, right, so that was another almost as straightforward as the first one, but the diagram is beginning to help. The next one, I'm now, well, let's do the diagram. 0, I need 5, I need the number either side of 5, which is 6 on this side and 4 on that side, if I remember how to count. I put the 8 on, I put ... Now, what do I tick now? 0 does not get a tick, because I want x to be greater than or equal to 5. 4 gets across. 5, it can equal 5, so 5 gets a tick, 6 gets a tick, and 8 gets a tick. Now how far is, and remember all my boxes always have to start from 0. So my box that includes the ticks has to come all the way up to the 8. So it's going to be all of this if I want to include all the ticks. So I need a second box which is going to remove the crosses, and that has to come as far as the 4. So this is the usual pattern. You have an inclusion box which makes sure that that grabs all the ticks that you want, and then you have to subtract away the exclusion box which has got the crosses that you caught in that first box. Okay, so that means I'm going to need to subtract 2 probabilities. I'm going to need to subtract the probability of x being less than or equal to 8. I'm going to start with that one, probability of x being less than or equal to 8, and I'm going to take away the probability of x being less than or equal to 4. Okay, but this is a little bit easier than it looks, because the probability, when I came as far as 8, I've included everything. So in fact, we can say the probability of it being anything from 0 to 8 is 1. So it's a 1 minus the probability of x being less than or equal to 4. I did x being less than or equal to 4, in fact, in question A. So it's 1 minus 0.9420. 9420, which is, I can do in my head, 0.0580. Now, the slightly annoying thing is that when you've got probabilities appearing like this on your calculator, and you then need to do something else with them, you're going to tend to have to go into menu 1. So if you have your good old GCSE calculator that you haven't thrown away, then I think there's a lot to be said for actually having 2 calculators out. One to work out the probabilities and the other to do your subtractions. So that's what I'm going to do. I've got my emergency backup calculator here. So let's see how we get on. The next one is for the probability of x equaling 2. So once again, we have all the outcomes from 0 to 8. I make sure I've got 2. I need the 1 and the 3 on either side of the 2. Okay, I can put ... here. Okay, well, now the only one with a tick is the 2. Everything else gets across. Okay, now I need the first box. I have to start from 0. I need to catch all the ticks, so I have to come as far as 2. There aren't any ticks after that. So that will do as my inclusion box. But this has got some crosses inside it that I don't want. So my exclusion box is going to come here. I'm going to get rid of these 2 crosses. So the first box has got all the ticks in. The second box, when I remove it, will take away the crosses. So I need to do, and the method that I should write down, is the probability of x being less than or equal to 2 minus the probability of x being less than or equal to 1. Okay. Now the probability of x being less than or equal to 2, I've actually already got. So on my second ranking calculator, I put 0.55177. Okay, and I need to take away, well, to find out what I need to take away, come back to my clever calculator, and I say, okay, I want the probability of x being less than or equal to 1. N and P don't change, so I just put 1 in, press equals, and I get 0.25529. So while I can see that, I get this, and I subtract 0.25528, in fact. Okay, so there, I've typed that calculation in, press equals, and this secondary calculator tells me the answer is 0.29647. Now, it's probably not a bad idea, actually, to write down that I did 0.55177 minus 0.296472. The reason why that's not a bad idea is because there may be marks for these answers appearing even if something's gone a bit wrong somewhere. But nothing should go wrong because you're using a really good method with the inclusion and exclusion boxes. Okay. As an example of that, people who try and do this one without the diagram, they get it wrong. They either use the 1 and the 5, or they use 2 numbers that aren't 1 and 5. In fact, it's going to turn out that we're going to use one of these numbers and not the others. But without drawing the boxes, it's very difficult to spot what you need to do. So we need 0, 1, 2, ... I need 5. I'm going to put the 4 in and 6 in, ... 8. Okay, so what gets ticked now? Well, I need to be greater than 1. So 0's no good. I need to be strictly greater than 1. 1's no good, so that's a cross. 2 gets a tick. 4 gets a tick. 5, I've got to be less than 5, so 5 gets a cross. All of these get crosses. My inclusion box comes as far as the last tick, so it includes the 4. And my exclusion box has got to remove all the crosses, so it comes that way. So I need to do the probability of x being less than or equal to, last number in my inclusion box is 4. take away the probability in my exclusion box. That's the probability of x being less than or equal to 1. So these are the probabilities that I need to subtract. This is going to be my minus 0.296472 again. Okay, that's another good reason for writing down the probabilities. You may find you're using them again. Have I done x being less than or equal to 4? Yes, I have. So I've written that one down before, 0.9420. So on my calculator, 0.9420 minus 0.296472. I've got different numbers of significant figures, but I'll forgive myself. And so my answer is 0.6455. I think I trust that to 4 significant figures. 0.6455 is my answer there. So I underline all of my answers so they're all nice and clear. So if you're lucky enough to get a question where there are a number of binomial probabilities to work out, then this is how to do it and get it right every time.